Before we go any further, I'd like to check that we've got all the jurors for this fight. On my list, we have Murray, we have Mladen, and I know you're all ready to go. We have Mercia. Could you just...
Yes, I'm here. I can hear you.
Okay, I got a loud echo when you started talking then. We have Carmen.
Yes, I'm here.
Okay, and we have Domagoj.
Can you hear me? I'm here.
Yes, I can hear you. That's
Okay,
good.
thanks.
Okay, before we start the captain's contest, I just want to suggest some solution to a problem that we had yesterday when one of the jurors couldn't see the stream of one of the, well, it happened a few times, presentation. They could hear, but they couldn't see. And I'm suggesting that what I'll do if that happens is I will stop the clock and I will ask the team to send their presentation just to the juror. The juror will have to alert me that they cannot see. So it won't become available to the other teams. But if it's sent in a direct message to the juror that's having trouble, then they can see the presentation, follow it along, and we can restart the clock. Okay, I've just received a direct message from team captain. That's of Greece-Fryganiotis. You'll have to tell me if I'm not pronouncing your team name correctly. Could I also please have a message from the other team captain so that I know that everybody's ready to begin? And then we can have the captain's contest. I'll just remind you what's going to happen with the captain's contest. So I need to have each of the three captains working independently. Okay, this means that you're not discussing the answers with the other people in the team. And of course, it means you're not getting any help from either the internet or from your team leaders. I will read out each of the questions one at a time, and you will need to send me within 20 seconds your best answer, just from the team captain's own thinking. Okay, I have a team captain of Switzerland. Thank you very much. So I will have a clock. You won't be able to see that, but it's just a 20-second clock. You can keep your own time. I'll read them out. Do let me know straight away if you need me to repeat the question. I'll try to pronounce the words as slowly and clearly as I can. So you'll send me a message with your answer, and once I've asked all the questions, I will go through the answers for everybody. And then we will work out the scores. If we have a tiebreaker, if we need it. Now, just a reminder that the winner of the captain's contest will be able to choose the order of the teams, and so the order of the presentations in the semi-final. They will choose team 1, who will be reporting first. Team 1 will also review second and oppose third. Then team 2, who is opponent in the first stage and reporter in the second stage and reviewer in the third stage. And team 3, who will review first, oppose second, and be reporter in the third stage. So I want to get started. I know that all the team captains are ready. So here we go. Question number 1. Here is a list of 5 mammals. Indicate the only one which is egg-laying. Arctic fox, Baluchistan pygmy jerboa, domestic cat, platypus, Western gorilla. Ten seconds left. I have two answers. It's 20 seconds. I don't have a response. Thank you. Question number 2. Here is a list of 4 numbers. Indicate the only one which is a prime number. 96, 97, 98, 99. Okay, I have 3 responses. Question number 3. The sun's magnetic field goes through a cycle and periodically flips. What is the duration of the solar cycle? What is the duration of the solar cycle? Ten seconds. Okay, I have 3 responses. Number 4. Arrange these 3 metals in the order of increasing density. Iron, lead, osmium. Ten seconds. Time's up. Question number 5. Arrange these 3 stars in the order of increasing visible magnitude. Aldebaran, Sirius, Sun. Ten seconds. Time is up. And the third one was Aldebaran, Switzerland. I'm sorry, your question came. Well, actually, it doesn't matter, Switzerland, because you got that one wrong. So let me just go through the questions one more time. The first question was, here is a list of 5 mammals. Indicate the only one, which is egg-laying. Arctic fox, Baluchistan pygmy jerboa, domestic cat, platypus, western gorilla. And the answer was platypus. And all 3 teams chose platypus, so all 3 teams scored 1 point. Number 2, here is a list of 4 numbers. Indicate the only one, which is a prime number. 96, 97, 98, 99. And the correct answer was 97. And all 3 teams scored a point. Question number 3, the sun's magnetic field goes through a cycle and periodically flips. What is the duration of the solar cycle? And the answer from Switzerland was 11 years. The answer from Greece-Fryganiotis was 11 years. The answer from Russia element was 8 years. So that is incorrect, and so 1 point to Switzerland and 1 point to Greece. Okay, question number 4. Arrange these 3 metals in the order of increasing density: iron, lead, osmium. Now the correct answer is the same as the order that I read them out. So Russia element scores 1 point for a correct answer. Greece-Fryganiotis chose iron, osmium, lead, so no point. And Switzerland chose iron, osmium, lead, so again, no point. That means that we have 3 teams on 3 points, 1 question left. Question 5, arrange these 3 stars in the order of increasing visible magnitude: Aldebaran, Sirius, Sun. And Russia element chose Sun, Sirius, Aldebaran. So that is the reverse of the correct order. And Greece-Fryganiotis chose Sun and Sirius and didn't rank Aldebaran. Switzerland chose Sun and Sirius, again, did not choose Aldebaran at all. So nobody scores a point for question number 5. And what this means is that each team has 3 points, and we will be going to the tiebreaker question. So team captains only, you've done very well, but you need to be ready now. Question number 6. Oh, and I need to get... Again, I'm going to be giving you just 20 seconds to answer. Make sure that you don't go over time, because I may have to use time as the deciding factor if more than one team gets it correct. So I'm going to read the name of a book in Latin and then in English. In Latin: De Revolutionibus Orbium.
Sorry, can you please repeat? Could you perhaps show the question on your camera?
Oh, you know what? Oh yeah, I can't type it. Like, I'm going to continue. I'll read it in English. The name of the book in English: On the Revolutions of the Heavenly Spheres, is the book by Nicholas Copernicus on the heliocentric theory. Estimate the year of its first publication. 20 seconds from now. I have 2 answers. I don't have an answer from Russia element. Okay, I'm stopping there. We have an answer from Russia element of 1541. We have an answer from Switzerland of 1498, and we have an answer from Greece-Fryganiotis of 1543, and the correct answer is 1543. So Greece, congratulations, you've won the captain's contest. So I would like you to tell me which team you would like to nominate as Team 1, which team as Team 2, and which team as Team 3. if you type into the group A text channel, that would be good.
Okay, I have decided the orders.
Okay, you can read.
Okay.
Can you read it out and
Yes.
also type it?
Okay. For reporter, the team Fryganiotis. For
So you want to
opponent,
you want to report first?
yes.
Yeah.
For
Okay.
opponent, Russia element. And
Yes.
for reviewer, Switzerland.
Okay. Thank you very much. So in the second stage, the reporter will be Russia element, opposed by Switzerland and reviewed by Greece-Fryganiotis. And in the third stage, the reporter will be Switzerland, opposed by Fryganiotis, and Russia element will be reviewer. So, Fryganiotis, are you preparing right now to report? Okay, that's very good.
Can you see my presentation?
Yes, I can.
Okay,
And
so
I'm going to bring a clock onto this. I'm
okay.
sharing a clock. Okay, now I just want to make sure that you can see the clock.
Yes, we can see it.
Okay, are you ready to start? Chris, are you ready to start?
Yes, I'm ready.
Okay, I'll start the clock. Oh, go.
Okay, hello everyone. My name is Menelos Raptis and I'm the reporter from Team Fryganiotis, Greece, presenting the problem number 3, which is called photography with iron salts. So these are the contents of my presentation, and this is the problem to be investigated. So according to the problem investigation, we should mix 10 parts of ferrous oxalate with 7 parts of concentrated ammonia solution and 20 parts of saturated solution of oxalic acid in order to produce a photosensitive iron complex.
Can you please talk loudly?
Yes, we should prepare separately 25% solution of potassium ferricyanide, and according to the problem statement, a sheet of paper saturated with a mix of these two solutions can be exposed to light and produce an image. So, when do we call a material photosensitive? Photosensitive materials attain properties that are distinctly different from those of non-excited materials. By absorbing energy from light, these materials temporarily change their solid state, molecular, and/or their facial properties. If the interface is sufficiently photoactive, these materials may also react with their molecular environments and generate chemical energy in the form of energy-rich compounds. So, the discovery of photosensitivity in 1978 by K.O. Hill triggered the development of new optical elements, mainly in fibers and waveguides. The principle of photosensitivity relies on the exposure of material with energy larger than its bandgap, as we can see here in the picture. So the linear or non-linear interaction generates a change of the material structure that induces a local refractive index change. So what is generally sound type and why referring to this procedure? Sound type is a photographic printing process that produces a cyan blueprint. Engineers used this process well into the 20th century as a simple and low-cost process to produce copies of drawings referred to as blueprints. The process used two chemicals, ferric ammonium citrate and potassium ferricyanide. In the experiment given, we use ferrous ammonium oxalate and potassium ferricyanide. The combination of UV light and the citrate reduces the iron 3 plus to the iron 2 plus, and this is followed by a complex reaction of the iron 2 plus complex with ferricyanide. So the result is an insoluble blue dye, also known as Prussian blue. So in the experiment, what happens is that we have two solutions. In the first solution exists the ferrous oxalate, the ammonia, and the oxalic acid, while the second one exists the potassium ferricyanide. And while mixing them, we will have a final solution which contains iron 2 plus, cations of potassium, cations of ammonia, and ferricyanide anions. So we have some interesting combinations. And from the first one, we are only interested in the formation of the Berlin blue, while the second one, we are only interested in the formation of the thermus blue. In my experiment, we have both Berlin blue and thermus blue, and their color difference is negligible. And there is also a chemical balance between them. So these are the parameters tested in my experiment, and I will move on them. So to measure all the above mentioned parameters, I use an open source platform used for building electronic projects, which is called Arduino. So for temperature and humidity, I use the DTH22 sensor, and the circuit that I made referring to this sensor appears on the right. So here's my hypothesis. We wait to observe a higher same number with higher concentration of the solutions. We wait to observe better results referring to the contrast control by using papers with a more absorbent surface. Higher temperature means more electronic traps, which means a higher photosensitivity. We will not observe change in the color if we let the paper under a LED light bulb. With a higher speed of the air current, we wait a bigger amount of water to be evaporated, and higher speed of evaporation of the liquid means to a lower optical density. And lastly but not least, the lower the pH, the more intense the final result. So here is my experimental procedure. It would be very subjective to compare the results only with the naked eye. And in this context, we are all looking for something really valid and really scientific. For this reason, I put a projector in a dark room and a distance of 10 meters of the paper in question. Behind the paper exists an Arduino photoresistor. Firstly, I measured the resistance written from the sensor with the paper, which has a solution of the problem statement. Then I did the same after the formation of the photograph. The difference between the two results and the comparing of the differences across the parameters changing is the solution to compare the photographs. So here's my first experiment, the original experiment, and we can all see a negligible difference. And this is why the problem uses iron 2 plus with potassium ferricyanide. That means we will observe from the start the thermus blue, which is the same in color with Prussian blue. And that is what we hypothetically wait to see after the exposure of the paper in the UV. So in my experiment, that didn't work. My second experiment is with ferrous and ferrocyanide by testing the parameter of the pH, and we can see clearly here that the paper with the lower pH has the biggest difference from all. And also the fifth paper was 1 week made, so that also tests if it works with a relevantly old solution. Here's my third experiment, also with ferrous and ferrocyanide, by testing the parameter of the radiation and also the time. So we can see here that the bigger the amount of time we let the paper, the bigger the percentage. And also, the bigger the radiation, the higher the percentage in our results. So the ninth was led to a LED light bulb for 24 hours, and we can see a negligible difference, something that confirms my hypothesis. And here are some of my photos from the experiment of the UV light. And here's my fourth experiment with ferrous and ferrocyanide by testing the parameter of the dry. And we can see here that the differences across all of the differences of the papers are really negligible. So here's my fifth experiment, and here I test the types of the paper, and we can analytically see the percentages written on a diagram in this slide. So we can see that in the bond paper exists the biggest percentage, and also in the white paper. So here's my sixth experiment, the traditional way with ferric ammonium citrate and potassium ferricyanide. And we can see a plus 7% difference between the recipe 1 and the recipe 2, which is a variation using more concentrated solutions. Here's my fifth experiment, also the traditional way and the UV. And here we can see some flowers to spot the difference. and we can see also a photo of my experiment. And here are my conclusions. So iron 2 plus combined with ferricyanide gives thermos blue from the beginning. Lower pH means a more intense blue. Usual light bulbs don't affect the color. All solutions work too by giving the present blue. The way of drying the papers doesn't really affect the experiment significantly. Higher temperature means contributes to raise the photosensitivity. FAC with the potassium ferricyanide works better a lot of times more than FAO with potassium ferrocyanide. And lastly, higher light intensity and more time of exposure means a more intense result, something that confirms my hypothesis. So here are my possible errors, and I will show them to you if it will be asked to me. And here are my references. So finally, thank you all for your attention.
Thank you very much. Now it's time for clarification questions from the Russian element team. Could I remind you before we start this that I do need the names of the reporter, opponent, and reviewer typed into the text channel.
Okay, I have a question. Did you apply the solutions in a dark room before the experiments?
All of my papers, yes, they were left on a dark room, except for one. And you can see in my presentation that I included them.
Can you please speak louder?
Yes. Can you hear me now?
Yes.
Okay. All of my solutions were left to a dark room. Yes, except for one, only for to experiment with it and see what's the difference from the others. But the official, the actual sound type, in the actual sound type, you should let the papers dry in a dark room in order not to have the color change.
Okay, I understand. But when
Yes.
did you take these photos? Because we can see the light on them.
Yes, those photos are from solutions that, yes, they were exposed to light, but only for the photos. For my experiment, I used other papers that are not included in my photographs because it is reasonable that I couldn't photograph them, right?
Okay. Okay, and how did you measure difference of photosensitivity?
Great. You can see in my presentation that I would say that it would be very subjective to compare the results only with the naked eye. So what I did is to put a photoresistor behind the paper in question before the experiment and after the experimental procedure so as to see the difference across the papers. So this difference between the two results and the comparing of the differences across the parameters changing is a solution to compare the photographs as I have already explained in my presentation.
Can you please show me the slide with the parameters which you have changed?
Yes, of course, the parameters and the constant. Give me a second. Okay. Basically, while loading, I can tell them to you. Or
We can't see the slide.
Okay.
can you see me now?
Yes, thank you.
Okay. Could you leave that slide visible? And we're going to the next phase, which is 3 minutes of preparation time for the opponent. Okay. It's time to move to the next phase. So,
Good
Russia, are you
afternoon.
ready to start?
Yes.
Okay, I've just paused for a second. I'm looking for your stream.
Can you see our presentation?
I will. Yes, I can see it now. If anybody can't see it, send me a message and we'll ask for it to be sent to you. I'm starting the clock.
Good afternoon. My name is Lisa, and I'm the opponent from the Element team. The speaker presented the solution of problem number 3, photography on iron salts. Speaker didn't show us a study of his work, aim of his work, so we can't know what he wanted to reach. In our opinion, the hypothesis of the study were formulated in accordance with the conditionals of the problem. In the theoretical part, the speaker talked about historical material about photosensitivity and discovery of photosensitivity and about sanotypy. But he didn't say about what is photosensitivity and why the iron is photosensitivity metal, which is really important in our opinion. He doesn't show us any formulas and chemical equations, so it's difficult to understand what happens in his experiments. In the experimental part, they choose different solutions and comparing them. They also have used different light, LED and sun, changing pH. But in the condition was set about studying more than one method, and they used only one method, which is TANATP, but they could study DTRTP and so on. They also used different paper and different surface in their experiments. Their graphs were small and misunderstandable. They didn't said about different salts. How can they change the experiments results? And as a result, in our opinion, the problem is solved partially. The opposition is over. I'm ready for discussion.
Okay, thank you very much. We'll move to the next phase of discussion. Please start.
Okay, can you please tell me why the iron is photosensitivity metal?
Okay, thank you for your question. It is my first of all, I have to say that the iron itself.
Can you please speak louder?
Yes. First of all, I have to say thank you for your question, and it is my firm belief that the iron itself isn't really photosensitive. The problem statement is itself states that the complex form it is photosensitive. And yes, I can answer you about the iron in our experiment. In the one case, we have the reduction of the iron. So if we put the ferric, it converts into ferrous. So we have this reduction and the formation of a complex, which is the Prussian blue. And in the exact opposite, in my experiment, because you asked about my experiment, we have
Okay, I understand.
yes, you can see it here in the formation.
Okay, but do you think that all iron salts are photosensitive?
First of all, I have to repeat that not they aren't, because iron salts aren't photosensitive. The complexes are photosensitives. Yes, I think that some complexes that are formed from some irons aren't, but the irons themselves aren't photosensitive.
Okay, I understand. I agree with you. But have you tried changing salts, for example,
Yes,
argentum?
yes. And because I had a lack of time in my presentation, I put it in my appendix so you can see here. You can see here in my appendix. Can you see this slide?
Yes,
That
thank
I
you.
have tried another method which is called argyrotype, and the results in in this procedure are mentioned here below, which is a difference plus 42 percentage.
Okay, I understand. And how do you think how much energy you should use uh, to change volume of ferrum
Okay,
from
so you
plus
are
3 to plus 2?
okay, so you are referring to this conversion, right? You can see here and to the radiation, of course, because you talked about energy. So you can see here in my slide, this slide, okay, the radiation, that is the energy from the sun, affects the results. And the higher the radiation, it can be from a UV lamp, it can be from the sun, it can be from anywhere. But the radiation plays a significant role, which means that energy plays here.
Okay,
Yes,
I understand. Thank
yes.
you. And what do you think? Can you use red light, for example?
A red
What
light
will
for
change in this situation?
Okay, thank you for your answer. In my experiment, I didn't use red light. It wasn't in my parameters, but I firmly believe, and I can answer you, and to be sure, that a red light wouldn't have, in no case, the same results as a UV lamp or as a LED light bulb that we saw that it hadn't any difference. Yeah, that's my opinion. And I think that no research from my experimental procedure has been made to test if red light has a result on this,
Okay, and
because
from your
that
words,
isn't that
uh,
isn't sound type.
okay, from your words, we can understand that you can change frequency of light. Am I right?
I think that in my experiment I have used different sources of light. So yes, I
But
would
can we
include.
do this like a parameter?
No, we can, because we know that it wouldn't have a different result. Okay, thank you for your suggestion. I would include it, but I didn't think that it's not that significant because I have tested already three different light sources, and
Okay,
that's
thank you.
reasonable.
Okay, thank you. I understand. That's all.
Okay, we don't have time
Thank
for
you.
any more. So let's go to the next phase. And this is clarifying questions of the reviewer.
So my first question is for the opponent, please. Just to clarify, did you agree with the reporter's claim that iron salts are not photosensitive?
No, because iron salts are sensitivity, but no, all it's salts.
Can you quickly explain why iron salts are photosensitive to the opponent?
Because only complex salts are photosensitive. They
Um,
can change their balance.
okay, I'm sorry, I couldn't understand. Can you please repeat your answer as to why iron salts are photosensitive?
Because they can change their velocity from plus 3 to plus 2.
Okay, thank you. And then a question to the reporter. Can you quickly explain why your
Can you repeat your question? I didn't hear you. reviewer.
Why
Switzerland.
are the tested green instead of blue?
You mean the Prussian blue in my experiment?
Yes.
Okay. So you can see that different chemicals used for this experiment give different colors. In my experiment, that was sound type. And as I said to you in my, give me a second, okay, in this slide, sound type can give these all colors. So yes, these are all, yeah, we can tell that it's blue.
Okay, thank you. So did you not create any Prussian blue?
Yeah, I created a Prussian blue. Of course, that was my experiment. That was my experiment. I
Where
created a
is the
Prussian
Prussian
blue.
blue? And why are your images green if you created Prussian blue?
Okay, we're over time,
Because
so
Prussian blue
you'll-
appeared like that.
we're
in my
going on to the
experiment.
next
Thank you for
phase,
your
which
question.
is going to the next phase, which is preparation of the reviewer. You have 2 minutes.
Can you hear me? Okay. So my name's Margot Lurie, and I'll be reviewing problem 3, photography with iron salts. So this is the problem statement. Here, so just some of the key points were to use iron salts and to produce pictures, which I felt was extremely lacking from the reporter's solution to the task. So here's an overview. The introduction to the phenomenon was pretty clearly explained. However, I believe he did not have good theoretical explanation because he was unable to explain why iron salts were photosensitive and the chemical equation of the Prussian blue that he created, in addition to lack of understanding of the reaction taking place. His setup was generally clear. However, none of his experiments produced any images or photographs, which the problem clearly stated. As for his data analysis, I could not understand what he measured and how he measured it, and he had no graphs or qualitative conclusions to any of the pictures he created, which I also felt was important because photography in itself is subjective. And then because of this, I didn't feel he was able to draw any concrete conclusions because he also had a lack of theoretical understanding. As for his theory, he did use potassium ferrocyanide and create the generally correct solutions. However, he did not have any theoretical justification for his hypotheses and no chemical understanding of either the reaction nor the Prussian blue he created. And he did not understand why the iron complex was photosensitive and said that the iron salt itself was not photosensitive. As for the opponent, she initially agreed with the iron salt photosensitivity and upon being asked was unable to clearly explain why iron salt was photosensitive after she disagreed with me saying she agreed with this statement. She didn't pick up on the lack of the images produced, despite the problem statement saying that this was a key aspect. And she didn't pick up on the green strips instead of the Prussian blue that the reporter said he created. She did point out the weaknesses in his chemical equations, but again, could not give explanations as to why iron salt itself was photosensitive. And then, as for the strengths and weaknesses of the reporter, he had no visual representation, and I couldn't understand his quantitative results and how he measured them. And he didn't have any qualitative results, which I felt was important, again, as I said before, and no explanation of his measurements. However, and for this, however, he did have multiple experiments. And then for the opponent, she again agreed that iron salts are not photosensitive, showing that she lacked understanding of the theory itself. And however, she did talk about some of the missing aspects of the reporter's presentation. Thank you.
First of all, I would like to thank the speaker and the reviewer for the done work. In the polemics, we made it clear that the speaker also studied different methods of obtaining photos, but didn't study the parameters such as the light frequency with which we irradiate the photo. Also, how we both found out it affects the result of the experiment. For example, if we take a red light, its energy will not be enough to take an electron to move to a higher level in the electron configuration. But I disagree with the reviewer that there were not enough images in experiments. I think they were enough. And I disagree that iron salts are not photosensitive.
Okay, now it's time for the reporter. You have 1 minute to make concluding remarks.
Okay. First of all, I have to say that I really enjoyed this whole fight. However, it is my firm belief that iron salts, not all iron salts, aren't photosensitive. An example of it is the iron 2 sulfate. The complexes made of them are photosensitive, not just the iron salt. If you put an iron salt, it won't change the color. And furthermore, I think that I had a lot of graphs and everything that wasn't clear could be asked. And last but not least, the color appeared in my experiment was undeniably a shade of blue, which is the Prussian blue. Thank you all for your time.
Okay, thank you very much. Now we have 5 minutes for clarifying questions from the jurors. And before you start, I'll just remind you that a juror is not an opponent. So we can have clarifying questions which are short and require a short answer, but you don't have to try and trick one of the competitors or challenge them too hard. Just clarifying type questions. Okay, I'm starting the clock now. Any juror that has a question? I can ask a question of the reporter. So there was some discussion about when the papers were exposed to the light. Could you just explain to me quickly at what stages of your process were done in the dark room, and then at what stage was light exposed to the papers?
Okay, thank you for your answer. The drying was done in the dark room, and when the papers dried, which was different times for the papers, and I included in my presentation as a parameter, the parameter of the drying. And after the drying of the papers, I exposed them either to the sun or to a light bulb or to a UV lamp and different sources.
Okay. So it was the ones where you had the photographs of the papers that had not been exposed. That's where you were saying that you only allowed light to touch the paper in order
Yes,
for the photograph to be taken.
except for the case in the UV lab, where when you can see in my presentation that in this case the paper was exposed to a dark room because the light source was the UV lamp, and the same procedure was followed in a light bulb. So yes.
Okay, thank you. Do any other jurors have any questions? Okay, I'm going to ask one more. So for the reporter, the opponent asked you to show the slide with all of the parameters that you tested, and there were two lists that came up. Could you show me that slide again, and can you explain which ones you tested and which ones you kept constant? Could you please
Okay,
present that
one
slide so it
moment.
gets a bit bigger?
Okay, so these are the parameters I tested and the constants. Of course, the humidity was kept constant. The temperature can be kept really constant because the papers was exposed to a light source, so that creates temperature. However, it was monitored by an Arduino sensor. The light intensity, of course, it was a parameter that I changed. The different photo sources, of course, the types of the papers, the types of salts was something that I changed. The electronic drives and the photo holes are a parameter really significant, and we can see that it is combined with the increase in the temperature. So this can be predicted through a theory, and this is the VSEPR theory that we can predict the crystalline structure and the imperfection of it. So I wouldn't tell
Okay,
that it's
thank
a
you.
parameter
I'll
that
just
is
stop you there.
constant. The P, okay, yeah.
Okay, yeah, I'll stop you in case there's any other questions. I just wanted to confirm that some of these were the ones you tested. Some of them you kept constant,
Yeah,
but
right.
this list includes all of the parameters that could affect the outcome. Any other questions from the jury? Okay, well, if we have no more questions, then I'll advance the clock to the next stage for the grading. And if the jurors could send me direct messages with their scores when they're done, please. Okay, it's time now for the results to be for me to read them out anyway. Okay, what I'll do is I'll try and type them as I speak so that you'll be able to see them in the text channel. And first of all, I will read out the scores for the reporter. And the scores are 15, 19, 20, 21, 23. The scores for the opponent are 12, 10, 11, 13, 12. And the scores for the reviewer were 9, 8, 8, 8, and 7. Now, I wouldn't say that there are a lot of variation or any extreme scores. However, well, not for the opponent or the reviewer, but for the presentation or for the reporter. Let me say for the reporter, I gave the highest score and I gave 23. Now, I gave extra points for the scientific essence and I gave 3 extra points for fulfilling the role because I found that at every stage, the reporter performed their role very well, defending their own solution, reacting to the critique. Every interaction was very nice. I didn't give any extra points for gamma, for structure, because I found that during the presentation, the way that the results were reported were on crowded slides. And it was very difficult to interpret the slide before you moved on to the next slide. So I would have given more points had it not been for that. The low score for the reporter was from Domagoj. So Domagoj,
I can comment. So
comment?
basically, because it wasn't really good structured and prioritized what the information will be presented, I couldn't really give, in my opinion, more to Alpha, even though I believe it was a good presentation and a good report. So basically, I stayed at 15, and compared to my other grades, that's a higher grade for me. Also, I can comment for maximum on review if you want.
Yes, please.
So I think that the reviewer captured the whole stage, the discussion, and gave its opinions. So I gave 1 point for each of the categories. So I ended up with 9. Thanks.
Okay, thank you. I would like Mladen to comment for the high score for the opponent.
Sure. Partial scores are 1.5, 1, and I was really hesitant on that one on beta, and then 0.5 on gamma and 0 for delta. I understood that the lady from Russia had some good scientific argumentation to express, but she didn't do it in a very convincing manner. And nevertheless, I think that these scores are more or less objective from my point. Thank you.
Okay. Thank you very much, Mladen. And I was a low scorer for the reviewer, so I could say that obviously it was a very good review. But I found overall it was a little too critical because I found that this was a very good science fight, better than we've seen in previous stages or previous fights. And so I think perhaps giving the reporter and the opponent a little bit more praise would have been appropriate in this situation. But otherwise, it was a very good review, and I still gave it 7, even though I was the low scorer. Okay, we've had.
Sorry, can I add a remark about the report before you close the fight, or did you have something else to say?
No, you can have the last word, Mladen.
Yeah, well, it doesn't have to be a last word, but just about the report, I gave 21, and I really consider that the scientific content was pretty good. I gave +3, and then I gave 2 for beta and point 0.5 for gamma and for delta. But I do believe that you had you had good scientific content, but you didn't really put a lot of effort to show it in a good way, you know, in your presentation. That's what Murray said, and I agree with that completely. You do have to make good effort to show your results in a well structured and convincing way, which you already had the data. You just needed to work on better presentation and summarization of your results. And some of your conclusions were a little shaky. They have to follow directly from your results, and you have to make that connection clear. So thank you.
Yes, I agree with Mladen. So the reporter, did a very good job. It's when you have done as much work as you did, it can be very difficult to summarize in 8 minutes what you did, and sometimes you have to leave out a little bit more, and so try and show depth of understanding. Okay, we are going to go now to a 10-minute break. We haven't had any breaks, and I'm actually going to eat my dinner. So we'll have a whole 10 minutes, and that means that yeah, just follow the clock. I would say what time it will be, but I know in New Zealand it's going to be 9:46 when we start again. Okay, the next reporter will be Russia. And could you please type the name of the reporter into the text channel so that we can start stage 2? Can I just check if we have all the jurors here? Do we have Mladen? Mladen, are you here?
Yes, did you hear me? Yeah. Hello?
Yeah, I do now. Yes. Mercia? Mercia?
His name is
Be
Mircea.
here.
Mircea. Okay. Carmen. Is Carmen here?
Yes, Carmen is here.
And Domagoj?
I'm
And
here.
Mircea is also here.
Okay. And I should just check that Switzerland is here because we can't start without an opponent. Switzerland, are you ready to start? Switzerland?
We're ready to start. This is the team captain of Switzerland. We're ready to start.
Thank you very much, Switzerland. So if everybody turns on the stream for the Russia element report, I'm starting the clock. So you can begin.
Good afternoon, my name is Nedikova Alina and I'm a member of element team from Novosibirsk, Russia, and today I'm represent our solution of the problem number 8, magnet and match. The condition of the task you can see on the screen. The hypothesis is, if after burning the match heads there is no oscillable interacting with the magnet, the chemical reaction results in substances interacting with the magnet. The aim of research is to study the causes of phenomenon of attraction of burnt match head. First, I want to show you the phenomena. Let's move on the theoretical part of our research. All magnetic substances are divided into two types. Weakly magnetics is diamagnetics and paramagnetics, and strong magnetics is ferromagnets. Diamagnetic molecules themselves do not possess magnetic properties, and when placed in external magnetic field, elementary currents are induced in them, weakening this field. Paramagnetic molecules are shallow magnets because of the thermal motion they are oriented randomly, that the whole body is not magnetized. In external magnetic field, the molecules rotate in the direction of the field, the body is magnetized and so enhances the external field. Ferromagnetics consist of small domains which are always magnetized, even if there is no an external field. However, without an external field, these domains are rotated chaotically, so that in general the sample does not show any magnetization. When an external magnetic field appears, the domains begin to be magnetized. The domains begin to be magnetized by the field, and the elementary currents create their own magnetic field, which were more than original external field. The properties of the magnet are determined by the two characteristics: is residual induction and the coercive force. The match length, match thickness, and match head length you can see on the screen, also the weight of match. Popular combustion on the internet you can see on the screen, but we think it's wrong and we use the another. Combustion temperature is about 800 degrees Celsius. When the head of match is ignited, the following oxidation and reduction reaction occur. Another reaction also occur, but they are rather difficult to predict. In the article, an elementary analysis was carried out as a result of which, among several types of match, the presence of ferrum was found in a match, which was attracted after combustion, unlike the others. And it was also experimentally determined that before the combustion we can found ferrum-2 oxygen-3, but after combustion ferrum-3 oxygen-4. Magnetite ferrum-3 oxygen-4 is a ferromagnetic mineral easily attracted by a magnet, and its absence in a unburned match explains the weak attraction. Reaction. Most likely a reduction reaction occurs similar to the following. The sulfur content in the head of match is high enough to the reaction to proceed. However, it's necessary to find the Gibbs free energy for the temperature in order to finally make sure that the reaction will proceed. If it's less than 0, the reaction proceeds. In our study, we have got a temperature about 800 degrees Celsius. In the formula, we have got 355 degrees Celsius, and the reaction proceeds. Consider all substances before and after the reaction that could have magnetic properties. You can see the table, and you can see that only ferrum-3 oxygen-4 has good magnetic properties, which explains the best attraction of the burned match to the magnet. However, if you use a strong enough magnet to attract, you can also attract an unburned match due to the presence of ferrum-3 oxygen-4. Which has magnetic properties. This is confirmed by the experiment on the next slide. In this slide, you can see the match before combustion and after combustion. The maximum weight that the magnet can hold by pulling the head will depend on the value of the magnetic induction vector determined by the residual induction, the match head surface area, and the angle between the vector of magnetic induction and the normal to the surface of the match head determined by the geometric dimensions of the magnet. A large mass of the mass will be attracted by a magnet with the highest residual induction and the large geometric dimension. In the first experiment, we measured maximum holding weight by peeling the head of match. In the next experiment, we used a different magnet, and we came to the conclusion, and we used the tracker program. And we have got graphics, and the conclusion is the distance from which the attraction begins depends on geometric dimensions of the magnet. The larger the magnet, the greater the distance you can pull a match or part of it. In the next experiment, we change the mass of match. Also, you can see a result. And the conclusion is the greater the degree of combustion, the greater the distance you can pull the match, because the weight of match decreases as it burns. Influence of the degree of combustion on the distance of attraction you can see on the screen. And the conclusion is the distance from a magnet from which the attraction begins is directly proportional to the mass of the match. And we can come to the conclusions. Investigate the reason why the head of burnt matchstick is attracted by a strong magnet. A burnt match is attracted to the magnet due to the increases in the content of ferrum-3 oxygen-4 during the reduction reaction, which has better magnetic properties than the original substances. Investigate the role of relevant parameters in the attraction of the burnt matchstick, and in all experiments we can do the conclusion that the higher the degree of combustion, that the more distance you can pull a match. The distance from which the attraction begins depends on the geometric dimensions of the magnet, and the larger geometric dimensions and the residual induction of the magnet, that the more mass the magnet can hold. Thank you for your attention. That's all.
Time for clarification questions.
Yes. So, why do materials become ferromagnetic? You didn't explain it. Reporter. Okay. Then what
Lily,
exactly?
repeat your question.
Oh, okay.
Could you repeat your first question?
Yes. Why do materials become ferromagnetic? Could you please give me an answer to why materials become paramagnetic?
Because it's characteristic of the.
Okay. And what is in the matchstick head? What is the matchstick made of? You never gave like what it is made of.
Can you repeat, please, your questions?
What is a matchstick made of?
We said about it. I can show you the slide.
Okay, thank you. And on your graphs, can you please tell me what the units are for the axes?
Distance and time.
For all the graphs or just for this specific one?
No. And in this slide, you can see a mass and distance.
Okay, and at the beginning of your presentation, you mentioned paramagnetism and diamagnetism. Could you explain quickly what those are?
You can see on the screen all the difference between it.
Oh, how many trials did you do per experiment?
Yes, 15 times.
Each experiment?
Can you repeat, please?
Did you test each data point 15 times?
Yes.
Okay, that's enough time. Our 3 minutes is up now. So could you move to the preparation time? Team Switzerland, are you ready?
Can you hear me?
Yes.
Okay, I'd like to start. Hello, I'm Lily Klein, and I'll be the opposition for problem number 8, magnet and matchstick. So this was the problem, and what I thought was relevant was to investigate the magnetism and also look at relevant parameters, and I thought the reporter did a pretty good job on these aspects. Then for the outline, the introduction was very good, and so was the phenomenon. The theoretical explanation was a bit lacking, since I thought there could have been more explanation on how magnetism works on maybe more atomic level. The setup was not shown, or not clearly shown, so I didn't really know what they used. Also, the experiments were lacking since she didn't explain them very well, and I had to ask what exactly the graphs represented since she just flew over them. The data analysis was okay since there were some graphs that were also nicely shown, and after I asked her, she explained them. For the conclusion was also lacking since she did not reference it back to her theory, since I also thought that her theoretical explanation was lacking. And also in the theoretical explanation, it was also, there were some slides where she just flew over and you didn't have time to really see what she did. Now, for the explanation of the theory, she did have a unique approach to the problem, so I thought that was very good. The definitions of magnetism were a bit lacking in my feeling, because she showed these nice pictures and then she just read out the text, and it didn't show really that she had any very good understanding of what she's talking about, but just reading the text. And I thought it would have been more interesting to see on a more of an atomic level what is happening in the magnets and why they become ferromagnetic, magnetic or paramagnetic or diamagnetic, and what exactly this does. And also, the explanation of magnetic properties was good. Yeah. And for the reaction, there were a lot of reactions, and it was kind of hard to follow sometimes what exactly she was doing. But she did show the iron oxide reduction, which in my view is a very important point. Though she did not emphasize it enough for my liking. She showed a lot of different equations, and I would have liked to see like a nice one. And then there was a lacking explanation of the experiments. There was no clear thing of what she did. The analysis, the tracking is a very good idea, and the experimental trials that she did 15 per data point, that is a lot, and I think that's very good. Then the combustion time for the experiment, that was a very good idea. But there was only pure text on the slide, so it was hard to follow. So we gave her 4.5 out of 6 on the chocolate bar scale for theory. Then for discussion topics, I'd like to talk about ferromagnetism, since this is a very important point in this problem. So I want to talk on it about more on an atomic level and what exactly happens and why things become ferromagnetic, and also the different domains, because she did mention that the domains align, but she didn't explain what the domains are and how this exactly works and what materials are ferromagnetic. For the first experiment, I would like to talk about what exactly she did, since she rushed over that and I did not catch this explanation, and also how she collected the data, and also kind of what exactly the graph represents. And for experiment 2, I'd like to talk about the consistency, and also if this graph that she showed was linear, and I would like to know if it would continue linearly, or if there is some kind of difference if you kept on going with this experiment. And now I'd like to go to the discussion.
So the first I want to explain you our experiment.
Oh no, I wanted to ask you first, for your second experiment, how does the continuation on your linear graph, how did you really represent that? Like, how did that work on your linear graph?
Okay, we use a tracker program.
On your linear graph,
we download the video and put access in the video in the center. And
can you show the slide before? Oh, but the slide before the conclusion. Could you please show that slide? Yeah. Could you please show the slide that's before the conclusion? Yeah, that one right before. This one. What would you expect if you kept on doing this experiment? Since the line is just a trend line.
Okay, I understand your question. So in this diagram, you can see the different mass, distance, and
okay, and how did you measure the error?
we got error in the program.
Okay, and how does this graph exactly relevant to this to the matchstick, to the problem? How is this relevant? Can you explain real quick what exactly this graph shows?
Influence of the degree of combustion on the distance of attraction.
Okay, then a question to the theory. Can you explain again how ferromagnetism works and how how ferromagnetism works and how things become ferromagnetic?
Yes, of course. Ferromagnetism consists of small domains which are always magnetized, and without an external field, domains are oriented chaotically. The sample does not show any magnetization. But in external magnetic field, the domains begin to be magnetized by the field.
Okay,
you can see on the pictures.
Okay, can you go back to the graph that we looked at before? Do you expect the line that in your experiments is linear? Would you expect that to continue if you continued experimenting more? Increase in the same way. Here, would you think that the line would keep on increasing?
Yes.
Why do you think that? At one point flatten out because you're burning the whole
Can you
match.
repeat your question? I can't catch it.
Why do you believe that this graph would keep on increasing? Why don't you?
Because gravity force will be increased.
But what if, because you are burning the whole matchstick, then you can't burn the matchstick more? That doesn't work. Wouldn't it stop at one point?
If it will, the mass of match will be more.
But if you keep on using the same matchsticks, wouldn't at some point, if you're burning it, wouldn't it? You couldn't burn it anymore, so it would start flattening out. Since there isn't any more part where this reaction that makes
Yes.
So you agree that it would flatten out at the end, the graph, and not be continuing as a straight line, as you mentioned before. And
it will be parabola.
Okay. One quick question?
Okay, sorry. We've got time up on the clock now, Lily. So it's time for us to go on to the next phase and invite the reviewer to ask clarifying questions.
Okay, thank you very much. Can you hear me clear?
Yes.
Okay, I would like to ask the reporter, does the room temperature and humidity affect the burning reaction?
Temperature influence, humidity no.
Okay, thank you very much. Also, what type of magnets did you use? Did you use multiple magnets or one just kind?
We use only one type of a magnet, but different size.
Okay.
And residual induction.
Okay. Answer. Also, about the opponent, which are the parameters that you could have put it in your presentation?
I would have liked to. What would be very interesting to test is different types of matchsticks. So maybe different types of matchstick colors or different types of magnets. And I think that would have been an interesting thing. But I think she did a good job with doing the tracking. That was a very good idea.
Okay, thank you very much. I'm fully covered. Also, I would like to ask again the reporter, how old were the matchsticks and magnets that you used?
New.
Okay. Also, did you use different types of matchsticks? Waterproof, windproof?
No,
Okay.
because we checked it, but only this matchstick will be attracted to the magnet.
Okay, I
Okay.
didn't actually start the clock at the beginning. The clock wasn't running, so I'm only going to allow you to ask one more question, and then time will be up.
Okay. How many times did you repeat each experiment?
15.
Okay, thank you very much. I think that's all.
Okay, so we'll move to the next phase, preparation of the reviewer.
Can you see my presentation?
We can see it. I'll ask you just to pause for a minute because one of the jurors is having trouble.
Yes, I got it.
Of course, no problem.
So I might need you to send your review presentation.
I got
to
the
one of the
presentation.
I'm
Oh,
sorry.
okay.
Okay, is everything okay? I can begin?
Yeah, everything's okay. You can begin.
Okay. Honorable judges, dear teams of the reporter and the opponent, my name is Florido Mirto from team Greece-Fryganiotis, and I'm the reviewer of problem number 8, which is magnet and matchstick. Okay, will we proceed explaining the reporter pros and cons? He had an excellent definition of the phenomenon. Moreover, he had a presence of visual aid and demonstration, a presence of hypothesis and interesting results, and last but not least, conducted the experiment multiple times. Although he had no good structure, he included formulas that are not estimated on the experiment. He didn't analyze the parameters. He didn't test parameters such as power of the magnet, room temperature, humidity, age of magnet and the mastic, type of the matchstick, and iron concentration. Moreover, he used only one kind of magnet. The experiments were conducted in a non-controlled environment. No possible errors and the reasons behind them were explained. He had an unclear method and didn't explain the graphs. The opponent pros and cons. She asked relevant questions to the theory, such as why the materials are ferromagnetic. The opponent highlighted the lack of definition and theoretical background, and also relevant questions. She asked relevant questions to the experiment. Although he didn't notice the missed parameters, such as the power of the magnet, room temperature, what interferes in the magnetic field, humidity, age of the magnet and the matchstick, color of the matchstick, and iron concentration. Moreover, he insisted too much on the ferromagnetism and spent too much time on it. Moreover, he didn't insist on the lack of possible errors and the reasons behind them in the experiment. The reporter versus the opponent points discussed. Okay, the opponent asked about the line representation in the graphs, and the reporter explained the used mechanism and the representation. The opponent asked how the graph was relevant to the problem, and the reporter explained the relevancy. The opponent talked about ferromagnetism and how the object become, and the reporter explained ferromagnetism. Last but not least, the opponent asked if the line in the graph would continue increasing if she continued experimenting and why. And the reporter said that it would flatten at the end. Okay, our opinion. We firmly believe that the graphs were relevant to the phenomenon. Moreover, it is our firm belief that the mechanism in ferromagnetic materials is caused by the aligning patterns of the constitute, and the opponent is right about the theoretical question, which we have no opinion on. Okay, suggestions for further improvement about the reporter. We will also propose the reporter to investigate the iron concentration through mixing a burnt match with ferrocyanide and observing the intensity of the color, include more significant parameters, and about the opponent to investigate the significant role of different parameters. Finally, thank you all for your attention.
I want to thank the reporter and reviewer, and I'd just like to say that in the discussion, I believe that the reporter did make a bit of a mistake with the linear graph, where she said it would just continue on, even though I believe that it would plateau at the end, since you cannot burn a matchstick more, and at one point you couldn't burn more mass. And she would say it would just kept on going, or was quadratic, even though after further insistence, she did agree with me. I agree with some of the points that the reviewer made, though I do believe that it is important for you to look a bit deeper into the ferromagnetism, though the reporter did have the basic knowledge on it, which I thought was already good. And with most of the points that were made, I do agree. Thank you again.
So it seemed to us that the opponent and the reviewer didn't get into the essence from our decision, because they asked questions about the information that was early used in the presentation. Also, we disagree with the reviewer about analysis the parameters. Also, she said about temperature, humidity, age of magnet, and matchstick, but the aim of our research was to study the phenomena. Also, we agree with the opponent about plateau. Also, we use only one type of the magnet, but we have got a different residual induction and geometric parameters, and we think it was correct. And we didn't change the humidity, temperature, and age of magnet and matchstick. That's all. Thank you.
Okay, thank you very much. It's now time for questions from the jury. So any jurors with a question can ask it now.
Question to the reporter, may I?
Yes.
Sure. You did have very good data from the tracker that gave you the change of coordinates in time, but it also provides you the possibility to calculate the velocities and the accelerations. And in that case, you had the mass and you could calculate the force directly. What prevented you from doing that? That's a nice way of reducing your data to, values that you could compare directly with magnetic attraction.
So we can calculate it, but it's not constant.
Okay.
We can show you it.
All right, thanks.
Can I ask?
Yes.
I was just interested, how did you calculate the error in mass of the match? How did you determine it?
So we take 100 of and calculate the mass, and after that
Okay, I'm sorry, Russia. I couldn't hear your reply just then, so I've just paused the clock. I'm going to ask you to explain again how you changed, how you measured the mass, or how you got the error in your mass.
and we have instrumental errors.
Thanks.
And divide by number of match.
But were they burned matches?
Can you repeat,
Or
please?
so those were burned matches or before burning?
Before.
Okay, thank you.
Do we have any other questions from the jury? I didn't see the graph again. You were going to show the tracker and how the velocity wasn't constant.
It was done constant.
Okay, reporter, could you please show slide number 23 again? This is the one that you have. I know it has been discussed several times already, but with slide number 23 on the x-axis of the graph, you have the mass of the match. And could you explain to me again how the mass of the match was changed in this experiment?
We use a match with a different degree of combustion.
Okay, can you pause on that one? So, okay, that's good. So the one with the largest, in these pictures, it looks like the one with the largest mass has the smallest distance, and the one with the smallest mass has the largest distance. Is that correct?
Yes. Because the more.
Okay. Any other questions from the jurors? Okay. In that case, we'll move on to awarding our grades. So jurors, just please send me your grades when they're finished. Okay, thank you to the jurors. I have all the scores, and I'll be reading them out and I'll be typing them into the text channel as well, starting with the scores for the reporter. We have 15. Sorry, I bet I'm reading the wrong one. No 15s. We have 20, 21, 24, 20, and 25. Scores for the opponent. We have 15, 12, 9, 16, and 18. And scores for the reviewer. We have 6, 7, 7, 6, and 8. So if we now have some comment, we'll begin with the reporter, and we'll begin with Domagoj, because Domagoj gave the lowest score.
So relatively to my grading standard, this is a higher grade. So I gave +3 for alpha and +1 for beta, +1 for gamma. And I think it was a good report. I believe that it maybe should be more practiced so that when responding to the questions, the responses are quicker and not just by reading the slides. But in other cases, it was a good report. Yeah, thanks.
I gave the
Okay,
other
I gave
20. I
Okay,
gave the other
yeah.
20. My partial grades are 2.5, 1 for beta, and 1 for gamma, which was I was really hesitant on, and I subtracted some points. You could have gotten higher grade there from me, and then 0.5 on delta. Thank you.
I gave the highest score, and things that I liked, first of all, was what you did, because in your experiments, you did some innovative things. It's very difficult to measure what's going on with a match head before and after it's burned, and you found ways to make measurements and use those measurements to get quantitative values that could be compared. So I was very impressed with that. I thought that the slideshow was it made a lot of sense, and I could clearly see what was going on. So I liked the way you presented the report in the form of the slideshow.
I must agree with
particular,
Murray.
that was what I liked.
I must agree with that, and I was really impressed. The only thing that I had objection with in that case was that you had excellent data, and you could have studied a little bit more, and perhaps further, to reduce the amount of data to the directly comparable quantities like forces, and perhaps you could have used electromagnetic field to regulate to kind of tweak the magnetic field intensity a little better and study the forces. But otherwise, congratulations on a very good work. Thank you very much, Alina.
Okay, for the opponent, the low score was from Mircea, and the high score was from me. So can we have comment on the low score?
Yeah, can you hear us?
Yes, there is a lot of
Hear us?
echo, but we can hear you.
Second.
Continue.
Yeah, so I gave such a low score because to me it felt like the opponent spent way too much time discussing trivial things such as the amount of text on the slides. And overall, I believe that not a lot of relevant points were brought by the opponent, and that's why I gave such a low score.
Okay. Anyone, before I comment with the high scores, For the reviewer, there were 2 6s. Would anybody like Domagoy or Mladen to comment on those?
Yes, I was afraid. I mean, I saw a lot on those slides, but they were kind of formulated in a generic form without a lot of specifics. Even though the report was pretty detailed and there was plenty to be actually concentrating on. And while we are at it, my partial scores are 0 on alpha and 0.5 on beta and gamma, 0 on delta. But returning to the opposition, where I gave 16, with partial scores of 2, 2.5, 1, and 0.5, I saw a lot of criticism there from Lily Klein, but in this case, it wasn't very specific. I mean, I saw a lot of argumentation being done against, what was being presented, but not enough specifics. They sound very categorical, but not much in terms of justification of those criticisms. Otherwise, thank you very much.
From
Okay.
me, if you
Yes.
want, for the review.
Okay.
So I didn't agree with some of the points that they brought up, and I gave +1 for beta because they did summarize the whole stage, and that's all.
Okay. Now, for the reviewer, I felt that they made many points, but and that in some ways it made it seem kind of rushed. But and if I did have another criticism, then I would say that there was some of the points that you made were slightly less relevant. More opposition questions. If you had been the opponent, they would have been good to include in the discussion, because I felt that the reporter felt that she needed to respond to those in her concluding remarks, which isn't really what the concluding remarks is for. However, the reviewer definitely showed her opinion and was balanced. So there was a lot of acknowledgement of what had been done well by both the opponent and the reporter. So, mainly I agreed with the reviewer. So I gave it 8. Now, for Lily, I gave 18, and I felt that at every stage, Lily did a very good job and performed her role very well. She definitely made me think. So when Lily was asking the questions, the clarification questions, I thought that those were relevant. They needed to be asked, and particularly things like there were some graphs. But yeah, let's always look at the graph critically, and we need to know what actually is on the axes and things like that, and how many trials, because again, it's quite important that it's not just one thing that's been done. So I felt that Lily's statement was very good. You gave credit for things that were done well, like using tracking to using tracking to try and analyze the motion of the bits of match head, and also you gave credit for the work done on investigating the effect of combustion time. Okay, so Lily, you did a good job, I felt, with your questioning during the discussion, and your concluding remarks were relevant as well. So I thought at every stage you did very well. Okay, let's can we have a shorter break this time? Instead of 10 minutes, we'll just take a 5-minute break. I'll find a way to put a 5-minute timer on the screen. And then when we come back, Switzerland will need to be ready to report. And Greece will be opponent. Thank you. Okay, Switzerland, are you ready?
Yes, we're ready. Can you hear me?
Yes, I can hear you. I'm just going to find the right place on the clock. And you can go.
Hi, my name is Ankit. I'm going to be presenting oscillating reactions today. Chemical oscillators, problem 14. So the problem statement says to get a sample oscillating reaction to propose a problem about a simple chemical oscillator. And my problem statement was to determine the effect of adding antioxidants to the BR Briggs-Rasher reaction and to determine the feasibility of such an assay to determine the antioxidant content of complex matrices, in this case fruits, using such a reaction. So here is an initial demonstration, a control. Over here, you'll see my absorbance for two different wavelengths, 350 and 250, which correspond to, although it's ultraviolet, it corresponds to the blue and the yellow colors due to their ionic counterparts. So you can see that you see periodic oscillations for the blue and for the yellow, and these are quite regular. We found the baseline time to be about 24.6 seconds, plus minus 0.5 seconds. And this is the reaction that we will be using going forward. Now we get to my theory. This is the initial equation. This describes the reaction as a whole. Now, as this one entire equation does not do a very good job in describing the oscillatory regime, I can then split it up into three sub-equations. Equation 1a, 1b, and 1c. Now, the first equation describes the iodate along with the hydrogen peroxide in the presence of sulfuric acid, reacting to form hypoiodous acid as the primary product. This hypoiodous acid reacts with the iodide ion, which in the current case is the dominant species, resulting in clear color, to form an I2, a diatomic iodide molecule. And therefore, that produces the yellow color that we see in the reaction. This iodine reacts with malonic acid. You can use any organic acid, but in this case, use malonic acid to then reform an I-. And this can happen through either a radical or non-radical process. The radical process being quicker, and it is the shift between a radical and the non-radical process that causes the oscillatory regime. So regardless, the iodide is produced, and since the I2 concentration is quite high and the I- is quite high, then these ions can then complex to form a further subspecies, a pentaiodide complex, which complexes with starch to form the blue-black color that we see. The I2 is then used up, left only with the I-, which then again causes this oscillation. Now, what's important to understand about the antioxidants is that antioxidants, by definition, would reduce free radicals. So over here, you can see the antioxidant reacting with
Okay, Switzerland, you've frozen. You've frozen on my screen. I'm going to pause the clock. Could anybody confirm whether they can hear?
Yes,
Can
it's
you
frozen.
Or is it me?
Can you hear me?
Okay, I can hear you again now.
Can you see my screen? No, they can't.
It's frozen. You're not moving on the screen.
All right. Let's see.
Sorry, we can't see the presentation.
Could you maybe just stop the live stream and then start it again?
Yeah, now it's back. Now it should be back. Can you see it?
I can't see it yet.
It's gone. Okay. Now it should be back. It's back.
Yeah,
okay,
now you're
yeah,
moving
it's back
again.
now.
Mute that. It's back now.
Yeah, I'm good.
Can you hear me?
Yeah, I can hear you.
All right.
So
perfect.
you can start again from the beginning of this slide.
Okay. So here you can see the importance of antioxidants. Antioxidants, by definition, react with free radicals and use them up. And as this reaction depends on two separate processes, the radical and the non-radical process, and the switching of the equilibrium between these two processes, since it uses up the free radical, not allowing the radical process to happen, it would thus quench the reaction for a certain period of time. And we can see this through the reactions over here. And therefore, we can derive from this that as we increase the antioxidants, we should also see an increase in the quenching time, which we will explore later. Now, this is my experimental setup. First, I had to take out I had to extract aqueous solutions from all the fruits. I used a filtration paper to ensure we got no solids, and I collected in small storage containers. I ensured that all the fruits were collected no more than an hour before the experiment to reduce the chances of oxidation, resulting in decreased antioxidant capacity. Then here we can see an overall preview of what the reaction setup looked like. We had waste containers, pipettes, the fruit juice samples, the ascorbic acid, and of course, we'll go more into detail into this central setup in the next slide, which you can see right here, where we had a UV spectrophotometer probe, which measures the absorbance of the reaction that is occurring in this test tube. We have a magnetic stir to ensure the entire reaction is uniform, and what the UV probe is measuring is representative of the entire reaction. We have clamps and stands to hold them, and the UV spectrophotometer probe fed it into a laptop, which I collected the data with. Now, here are the fruits selected. I selected 4 citrus fruits, 2 types of apples, pomegranate, peach, grapes, to ensure a wide variety of antioxidant capacities, which we could then measure. Now, here's a second demonstration, and you can see the blue peaks again corresponding with the blue over here. This is when, on the third peak, is when the additives were added, and you can see that it took a while for the peach to then recover due to the antioxidants being added. However, it took an even longer time for the grapefruit to recover, and this is due to the fact that, if we go to the next slide, that peach has the peach has a lower antioxidant content than grapefruit. Grapefruit has a higher antioxidant content, so you can see it also has a higher, what we would call, the inhibition time. It is 66 seconds compared to 128 seconds, and this is a number that we will be referring to continuously throughout the presentation. Now, here's an initial proof of concept where we use ascorbic acid, different concentrations of ascorbic acid, and we measure the inhibition time. And you can see there's a really strong linear correlation between the two, which proves the idea that we would see, at least in this range, a linear correlation between the antioxidants added and the resulting inhibition time. The equations are over here, as you can see. And yeah, so this is the ascorbic acid curve, which we will also be referring to later. Now, this is the inhibition times of various fruits that I measured, the 9 different fruits, along with their corresponding inhibition time. It's important to note that for fruits like grapefruit, the green star apple, and pomegranate, they weren't measured directly. We had to ensure that they stayed within the linearity of the curve we discussed earlier, and so they were diluted by a certain factor and then multiplied up based on that. And here you can see the peak inhibition time, of the different fruits and the antioxidant content taken from literature that was based off of the FRAP assay, a widely commonly used assay, and you can see a really strong linear correlation there. Now over here, we can use these 2 graphs to then determine the ascorbic acid equivalence. You take the inhibition time from the different fruits, use the ascorbic acid equivalence, and use the ascorbic acid curve, and based on that, you can determine the antioxidant content in the form of AAE, ascorbic acid equivalents. Most different assays use other equivalent forms, so gallic acid equivalent, maybe an iron reduction equivalent. This one uses ascorbic acid or vitamin C, the most common antioxidant. So in conclusion, you can see here, if I then graph my ascorbic acid equivalents, in other words, the antioxidant content that I measured versus the antioxidant content that's taken from literature, we can again see, even at the highest regions, we can see a very, very clear and strong linear correlation, proving that this novel way to address antioxidant content is in fact feasible. You can base antioxidant content measurement off of an inorganic reaction, which I think is amazing. And so the really strong linear correlation proves that it's feasible. And now if we just end off with the discussion, next slide. This was my original problem statement: determine the effect of adding antioxidants and the feasibility of an assay, determine the antioxidant content. And again, as discussed before, we can see that there is a linear, in this domain, there is a linear relation between the two. And so we determined the effect of adding antioxidants. And we found that the feasibility of such an assay is quite high, seeing the very strong correlation between published literature and my own measurements. So yeah, thank you for your attention. And I welcome any questions from the opponent now.
Okay, opponent.
Yes, can you hear me?
Yeah,
Yes.
I can hear you.
Okay. First of all, thank you for the presentation. I would like to ask
Yep.
you What is the period of the oscillation?
What is the period of the oscillations?
Yes.
Well, the baseline period and control where where there were no antioxidants added, if we can go back a couple slides, is about 24, is an average 24.6 seconds plus minus half a second. And so that was what we measured as the baseline. If you were to add in antioxidants, obviously, then the peak to peak time, so the inhibition time, would increase, and that is what the basis of this entire assay is built upon.
Thank you. And the total time of this?
Sorry?
And what was the total time of the oscillation?
The total. So I mean, usually the Briggs-Rasch reaction extended for about 20 peaks, so 20 oscillations, before eventually one of the reactants was used up. In most cases, it would be the malonic acid was used up, and then the reaction would stop forever. However, as you can see here,
Oh, yes.
this one is
Okay, thank you. Satisfied
yeah.
with your answer. And you stirred the solution with a magnetic stirrer, right?
Yes.
Did you test the temperature of the solution?
No. So I mean, well, the temperature was kept constant across all trials because it was all
Okay.
occurring at room temperature.
Yeah.
And there was yeah.
And yeah, thank you. That was good enough. And I would like to ask you, did you could you tell me your analogies that you had in your solution?
I'm sorry. Can you repeat the question a little bit louder? I can't hear you.
Yes, of course. Could you tell me the analogies that you used in your solution?
You mean the reactants that was based that the Briggs-Rasch is based upon?
Yes, and their analogies. How much of it you put, their concentration.
Oh yeah, sure. So if we can go into the appendix, there should be a recipe slide um, with the different solutions. Yeah, so the Briggs-Rasch reaction is based off of three solutions. Solution A, you can see here. Solution B, solution C. This was the simplest version of the Briggs-Rasch reaction I could find. Solution A takes, this is all within an entire liter, all these measurements. Takes potassium iodate, sulfuric acid, malonic acid, magnesium sulfate. That's just as a catalyst, grams of starch, and hydrogen peroxide. And sorry,
Yeah,
this is for
thank
500 mils of each solution.
you. Thank you.
And then you can mix, we mix 5 mils of each to form
Okay,
that
thank you.
reaction we saw
And
earlier.
one last question, please. What was the steering speed?
What was the what?
The steering speed.
The stirring speed was, if maybe we can go back. Uh, we kept it constant across all of them. You can see it's about a 4 on this magnetic scale, and we kept it the same across all of them. I don't think this would be super relevant. It's just to
Okay,
make sure that it's uniform, the entire thing. It's not to incite a reaction.
Okay, we've run out of time. I just want to point out before we go to the next phase that one of the jurors missed some of the stream. So if the teams could, or if the reported team could please send a slideshow to Domagoy, that would be helpful. Okay, it's preparation time now for the opponent.
can you see my presentation?
I can see it.
Okay, then shall I start?
If you're ready, yes.
Yes. Okay. So, hello, ladies and gentlemen. My name is Mirtada Terciado. I am from Team
Sorry, but
Fryganiotis.
can you speak louder, please, because I can't hear you.
Yes. Yes, of course. Hello, my name is Mirtada Terciado. I am from Team Fryganiotis, from Greece, and I'm here today to be the opponent to problem number 14, which was chemical oscillation. Oscillators. So for the reporter's theories, the pros and the cons, they had sufficient theoretical support for the results. They included some of the relevant parameters. They had a lot of visual aids, so videos, photos, graphs, GIFs, etc. And they had some really interesting conclusions. However, they did miss some important variables like the temperature of the solution, the concentration of the ingredients that I asked about, and some more that I will talk about in our discussion. They did not have enough sufficient theoretical support to justify the results. I will have some questions about that later. They didn't refer to their possible errors. Also, we'll talk about that, and they did refer to some crucial definitions. For the experiment, they were very well conducted, and they had a very clear experimental setup. However, they didn't include a hypothesis. They did not test enough parameters. They did not explain the possible errors that always exist in our experiments, and they did not present enough data. So to conclude, they define well most, if not all, of the relevant theory. They did not mention the importance of the solution temperature and the steering of the solution and other parameters. They conducted and showed the experiments very well. They did not mention and explain the causes of the errors and the errors themselves in their measurements, in the experiments, etc. They were not clear about how the conclusions were justified by the experimental results. And again, they did not include any hypothesis in the beginning. So suggestions for further improvement, they should add some hypotheses. It's very basic in order to see what we're expecting and also to justify our results. Since the hypothesis should be based on the theory, they should test more parameters, although they did test some, not all of them. They should add definitions like what is a chemical oscillator. They did not mention really important stuff. They should mention their possible errors and the reason behind. They all exist in our experiments, and we have to mention them to be valid. They also should perform more experiments in order to make the interpretation even more valid, and add error bar in the graphs. They did have error bars in some of the graphs, but not all of them. And they should examine the role of the person to the outcome, which is really, really important, which is why I've mentioned it so many times. And yes, that's it. Thank you for your attention.
Okay, let's start the discussion. And I also found the opponent fairly quiet, so if you can just remember to speak loud so that the other groups
Oh,
can hear
yes,
you,
I'm
please.
sorry. I will keep it in mind during our discussion.
Thank you.
Okay, so my first question is, when does the reaction stop?
Sorry,
Okay,
can you hear me?
yes.
So thank you for your presentation. The oscillations, you have about 20 oscillations in the reaction before the reaction stops. And in terms of some of the things you said for temperature relevance, concentration of solution,
I will talk about them later, please. Just
Okay.
wait and answer my questions that I'm asking you now, if you
Sure.
could do that. So just specifically answer my question, when does the reaction stop?
Again, it stops after about 20 oscillations. So
Okay,
that
and
would be,
why does it stop there?
well, this is because the malonic acid, one of the reactants, isn't produced. So the iodide, the pentaiodide complex, and the I2 are all produced during the reaction, whereas the malonic acid isn't. And so when it gets used up, then you see the reaction stop.
Okay, thank you. And what is the specific role of your ingredients that you use? Like, what does each and every one of them do? Do you know that?
Yeah, I do. So I showed you the ingredient slide from before. If we could just, can you hear me?
Yes, I can.
Yeah, so as I said before, I went into the ingredient slide. If we can just maybe put that up now. So we have all of these different ones. The H2SO4, so the sulfuric acid, is for the acidic, just for the acid within, for the H plus, the protons that are donated, and that is used in the theory that I mentioned earlier. The KiO3, the potassium iodate, is just used for this iodate ion over here. The malonic acid is used as a reactant. Magnesium sulfate is used as a catalyst. The starch is used to indicate blue-black color for the pentaiodide complex, and the hydrogen H2O2 is used as a reactant in the reaction again. Hydrogen
Okay,
peroxide.
thank you. How do you know that a certain color from the first oscillation was the exact same as the same color of the second oscillation? How did
Well,
you measure that?
in my appendix, I think I have a couple of more graphs. Well, yeah. So, this is the HCR probe, how it functions. So it essentially measures the absorbance of certain nanometer wavelengths. In my case, 250 nanometers and 350 nanometers, which correspond to the spectrum of
How
the.
did you measure that exactly?
What?
How did you measure that?
How did I measure what the absorbance?
Yes.
Through the ATR probe. So I set the data collection to 250 nanometers and 350 nanometers. Note that these aren't visible during the UV section, but they correspond to the absorption spectra of the
Okay.
two
Okay, thank
ions
you.
that I was trying to measure for.
Thank you for your answer. What is the role, or do you think optical density plays a significant role in your experiment? Because I did not see you mentioning that yet.
Optical density?
Yes.
What do you mean by optical density?
Oh, it's okay. It's not in here.
Optical density is generally defined as, well, the speed that the light can pass through the medium. So let's say the solution.
Oh, yeah. Okay. So certainly it's been controlled because the density wouldn't have changed from reaction to reaction. You would have the same medium being produced every single time because you have the same reactants, the same
So it's not
solution.
relevant. That's what you're saying.
So it's not, yeah. So it's not relevant in this case. I didn't
Okay.
do any measurements on it.
The thing is, if you change the optical density, if the optical density changes, it means that the analogies that you use change, which then change the entire experiment and your entire solution. So maybe you should have experimented with that a little bit more. And now, but
I don't think that would be relevant. I mean, excuse me. I don't think that would be relevant because I had the exact same solution. I'm using
did
the
you
same.
measure that? Did you measure that?
Did I what?
Did you measure that?
Yeah, because I created every single solution and I had large. So it was all the solutions were created as one, and I used small amounts of the same solution. I didn't measure the density
Did
because
you
it
measure
was
that
the
again?
exact same solution. It was
Moving on to my okay, thank you. Moving on to my next question about the temperature of the solution. Do you not think it plays a significant role?
I'm
Yes or
sure.
no?
I mean, this is a chemical reaction, so I'm sure temperature plays a role, but temperature was kept constant across all the different
Okay,
trials.
so the thing is, the larger the temperature is, the smaller the oscillation period and the total time is. But also, it's hard to keep the temperature constant, since while you're stirring it, while you're still stirring the solution, the temperature goes down. So you should have tested that. I would highly suggest you to do that for your next experiment. It is very significant.
I don't think that it's relevant because it was carried out in
Okay.
a controlled lab environment. The temperature was kept constant.
I'll have to stop you there. If you want to respond, you'll have concluding remarks later. Now it's
Sure.
time for the reviewer to ask clarifying questions.
Well, thank you. I have a question to the reporter. Well, how have you measured the periods of the reaction?
How have I measured the what? Sorry, I was unable to understand.
Period of the reaction.
The period.
Yes.
So as you can see here from some of my sample data, of course I conducted 3 trials for every single data point that I've shown. I've shown error bars on every single one, which is plus minus 1 standard deviation. But essentially the period is just the distance from a peak to the next peak. It's a standard definition of a period in an oscillation. And all you have to do is to just measure that distance in seconds, and that will give you your period.
Okay, thank you. And another question. Have you added just juice from the fruit, or maybe you have cleared the juice before adding it?
I added, the juice or the aqueous extracts from the different fruits, and I added a standard amount, about 500 microliters for each juice.
Okay, why are you so sure that antioxidants influence the reaction and not another components of the juice?
Not the what of the juice? The antioxidants in the juice, or what?
You know that juice includes not only antioxidants, there are also different acids, ferments, for example, and so on. Why are you so sure that antioxidants influence on the reaction but not another products of the juice.
So over here, you can see that that's why initially, as a proof of concept, first used ascorbic acid. Ascorbic acid, or vitamin C, is probably the most common antioxidant. And this was pure ascorbic acid of varying concentrations. And this shows that it's the antioxidants having the effect and not other things. I also used previous literature for other types of pure antioxidants to see. However, complex matrices weren't experimented as much. And I thought this would be my novel contribution in this field.
Okay, thank you. We've gone over time. So now it's preparation time for the reviewer.
So I think that I can start.
Yes.
So good afternoon. My name is Kashin Satisia. I'm the reviewer from Team Element from Novosibirsk, Russia. And today the speaker presented us the solution of the problem number 14, the chemical oscillators. The speaker didn't show the aim or maybe the hypothesis of the study, so we don't know what the reporter wanted to reach in the end of his study. In the theoretical part, the speaker talked about different graphics of dependent the intensivity of ultraviolet light on time, but I don't at all understand why the ultraviolet light depends on time. Also, the speaker demonstrates us the exact reaction, or what is a good side of the study. Also, the speaker showed us different scientific themes of the different foods he used, but I don't know what was it so necessary to put this in the presentation, but so let it be. Also, the speaker presented us exactly reactions which were in the experiment, which is very good because it was with them was easier to understand what was happening in their experiments. But we also think that it would be better if the speaker also told us about antioxidants, maybe the composition of the food, to better understand what exactly influence on the reaction when we add a fruit juice. So in the experimental part, some experiments were carried. For example, the speaker demonstrated us a demonstration of peach and grapefruit reaction, but show us different graphics, which helped us better understanding of the experiment. But there is a question that grapefruit has higher acidity, and if it may somehow influence on the duration of the experiment. So also the reporter used inhibition time of food. So and the main question to the reporter that why he thinks that exactly the antioxidants influence on the reaction and not other components of the fruit juice. So let's talk about the opponent. I think the opponents have understood the task very well. He asked different questions. For example, he asked, when does the reaction stop? And the coincidence of colors of revisions of several periods. So it helps us to get understanding of the task. So we think that the task is solved partially because we think it was better to say what exactly influenced the reaction from the fruit juice and the polemics took place. So the review is over. Thank you for your attention.
Oh, sorry, my microphone was muted. It's time now for the concluding remarks from the opponent.
Okay. I would like to firstly thank everyone for this amazing debate. It was really exciting. The presentation of the reporter was really interesting. I would like to apologize if I wasn't loud enough. It is a technical issue. I hope it wasn't too difficult to follow our discussion and my presentation as the opponent. I overall really enjoyed this, and I hope that the reporter can fix some of the things that we mentioned about, and also test even more parameters out because they didn't test nearly as many as they could or should. But it was overall amazing, and I'm real happy that I was part of this debate, of this discussion. Thank you.
Okay, thank you. And it's now time for the reporter to make concluding remarks.
Thank you. I hope you can see my slide. So first of all, I want to thank the reviewer and the opponents for their discussion. But two things I wanted to address that they both picked up on was the first, I didn't have hypothesis aim or didn't test enough relevant parameters. I just want to make it clear that this was the hypothesis aim, that if I would increase antioxidants, I would increase the quenching. The aim was to, of course, make the assay, which was in my interpretation of the problem. And in terms of relevant parameters, I'm not actually investigating the BR reaction itself, but I'm investigating the feasibility of an assay. And therefore, it is that novelty which I'm investigating which is important. The second thing was the error bars, or the possible source of errors. I show error bars for all of these. It's plus minus 1 standard deviation as I carried out 3 trials for every single data point. As you can see, perhaps in the lower part of the right graph, the error bars are incredibly small, and so it may be difficult to see them, which if you see the next, maybe the graph after this, which is why you don't see the error bars here. The error bars are just so small, so insignificant that you can't see them. But I hope that cleared up some of the confusion that you guys might have had.
Okay, thank you very much. We'll move on now to the questions from the jury. So any juror that has a question can ask it now. Domagoj, do you have a question?
No, sorry.
Okay, I can start. I have a question for the reporter. So you showed the oscillations when you were using the inhibitor to quench or the antioxidant to quench the reaction. And you showed a measurement of time on one of the graphs where one of the oscillations was delayed. Were all of the oscillations delayed, or was it just one during a sequence of oscillations?
No, so only a singular. Actually, if we go to the next slide. See, as you can see here, do you see my slide?
Yes.
So you can see that the original ones have the same baseline of about 24 to 25 seconds, and which is why I waited for the third peak to ensure that it got into a regular rhythm. I then added the antioxidant, and the initial recovery was a little bit low. The absorption rate was a little bit low, and this is because there's still some residual effects. By the time we got to the oscillation after that, it then resumed its normal baseline periodicity time, which we confirmed, and we measured all of these, and it came out to be the same baseline as we measured earlier.
Okay, thank you. Yeah, I was just unsure about when the antioxidant was added. Thank you.
Can I ask just, so you mentioned that the temperature was constant, but did you try to measure the temperature of your solution?
No, I carried out all the experiments in a controlled lab environment where it was set to 23
I mean, did the reaction create heat or something like that?
This reaction doesn't create that much heat. That's not something that
Did you
is
try to measure it?
product. No, I didn't, because I didn't think it was relevant to this problem. It was all being held in the same temperature environments using the same solutions, etc. So if there was heat being produced, which according to previous literature, there shouldn't really be, but even if there was produced, then it would be the same across all of them. And this wasn't exactly relevant to
thank you.
the purpose that I wanted to measure.
Okay.
Question to the opponent, may I?
Yes.
Hello? Well, I was looking at, I was listening very carefully to what you were saying, and apparently you were trying to make a point that humidity might, oh, I'm sorry.
Can you hear me?
Not enough parameters tested. Which parameters, for example,
Yes.
would you have
Okay.
considered also?
Thank you for your question. First of all, I did not mention humidity. I don't place a role
Okay,
either.
I
So
may
I
have
don't
heard
think
it,
should
but
have been
that
tested.
may be a mistake. Yeah.
Okay. Other parameters that he could have tested, is that what you asked me?
Okay.
Are you asking me to mention what other parameters could have been tested?
Yes, and also you mentioned that the hypothesis didn't exist. Wasn't there a hypothesis presented in this report?
Okay. First of
About
all,
the antioxidant role,
have
etc.
I might have missed the hypothesis, but I did not think. And in terms of the parameters, they could have talked more about the concentrations of the ingredients used. They could have mentioned the temperature of the solution, which is highly important, which is why I stayed on that for so long during our discussion. They could have talked about photo holes in the iodine that they used, or they could have talked about optical density. I also.
Your sound is fading. I'm sorry.
Oh, I'm sorry. Do you want me to repeat what I said?
Yes, if you could, the last part, the
Yes.
most important.
Okay. Yes, I said that parameters could have been the concentrations of the ingredients. She could have talked about the temperature of the solution, which is important, which is why I stayed on that for so long. He could have talked about the optical density, which is also very important. He also didn't mention about the steering speed, which actually plays a role in this experiment. And they could have tested a lot more stuff, but these ones that I just mentioned are the most important ones that I was actually surprised that they hadn't tested.
Okay.
Okay, thank you. Could we have any very quick questions from the jury? Okay, let's move on to the grading. So, well done. Okay, I have all the scores, so I'm ready to report the scores, and I'll read them out. And of course, you can check the text channel as well, as I'll be putting these in here. Scores for the reporter are 22, 22, 21, 23, and 27. Scores for the opponent are 17, 15, 14, 13, and 17. And scores for the reviewer are 6, 7, 7, 6, 7. So we can ask for a little bit of justification. And first, the low score, Mircea, for the reporter.
I gave the smallest score, not the highest.
Yes, the lowest score. I gave the highest, so you go first.
Yeah, the presentation was good. Like I gave the lowest score, but I liked the presentation. The scores are really close to one another, and the average pointing for a report would be 15, and I'll give 21. There's not really a justification to it.
Okay, that's fine. I gave the highest score. I had to give more than the previous one because I think that this presentation showed a lot of ingenuity. I think you should be very proud of what you've managed to achieve. I was impressed. There were points raised by both the opponent and the reviewer, and that were very valid and relevant. But I think you handled those points well. Let's go on to the opponent. The low score for the opponent was Mladen.
Yes, my partial scores were 1 for alpha, 1 for beta, 0.5 for gamma, and 0.5 for delta. And I was really hesitant on this 0.5 for gamma. And you probably figured out what was the problem there with when I asked the question. And so that would be a justification. I think that this is a reasonable score for the opposite. Thanks.
Okay.
As far as the reporter, perhaps, if I may add,
Okay.
my partial scores are 3, 2.5, 2, and 0.5. And this was the highest score that I gave in this round, in this fight, and I believe that it's very well deserved. Congratulations to the reporter. Very good scientific level of your presentation. Thanks.
Okay, I would like to invite a comment from Domagoj for the opponent because he gave 17.
Yes, so I believe it was a really good discussion, and that the opponent knew the matter that he was asking, and so I gave points for alpha, beta, and gamma, and that ended up to be 17.
Okay, I gave the highest score as well. I matched that with 17. I thought that you added a lot to this. That your clarifying questions immediately got me thinking, and your statement was balanced. It was fair, and definitely added to our understanding of the science. You asked about this stirrer and the effect of the stirrer on the outcome. You asked about the temperature, and you also asked about the total time. But all these questions were very well handled by the reporter. And I also found that if we can move to the reviewer, we all gave very similar scores. I felt that the questions asked by the reviewer also added to our understanding of the science and got me thinking again about, especially when you were asking about the other components of the fruit juice. This is actually something that I'd been thinking about since we saw the report, and what effect they would have. if I can just come back to the reporter again, and I said you can be very, very proud of your work. And I think the one thing that's missing is that whilst you have got an empirical relationship between the level of antioxidant and your inhibition time, you don't have a theoretical time predictor, which I think would finish it off perfectly. Now, does any other juror want to comment on any of the grades or indeed the fight overall?
With everything you said, the only thing I probably would have been more objective if I had added a couple of points to the review in this case. Thank you.
Okay.
I just wanted to say this was the fight that I saw the most discussion in this tournament. So thank you all.
I agree. Oh, I don't want to say anything negative, but I do want to point out that there were times during the discussion when the opponent was accepting answers and moving on quite quickly without actually giving their opinion on the answer. And yeah. However, yes, I agree with Domagoy that this was the fight that had the best discussion during this tournament. So I would like the jurors to give a round of applause to everyone who competed in this morning's fight. And can you do that by turning on your cameras and your microphones, and then we'll give them a little clap.
Great job.
All right, thank you. I'll be submitting the scores, and then you can find out who's made the final.
Good night, Murray.